Hi everyone, today we're going to be talking about section 7.4, multiplying a polynomial by a monomial. And just to review, a polynomial means many, and a monomial means one. So this is a one term, and remember we defined our terms in the first video that you had to watch as a number being multiplied by a variable. There's the number and then this variable. Sometimes monomials are just a number without a variable, and sometimes they are a variable and are missing that front number. Anytime this happens where you have a variable, it could be an x or an x squared, it's got that imaginary 1 in front, and sometimes that helps to put that in right away. Alright, so let's get started. Here are the first two examples, and I'm going to show you a couple different ways to do these. One of these is the way that you've been doing these for years, and right now we're multiplying 3 times the quantity of a plus b. So if I want to multiply into addition, we use what's called distribution. I take 3 times a and 3 times b. And it's not enough to draw the arrows because that really doesn't tell you what's going on. So 3 times a plus 3 times b. When writing multiplication, this becomes 3a plus 3b. And it asks me to simplify, so I want to double check. Are these like terms? Well, they have the same coefficient, the same number in front, but they don't have the same exponent. This is an a, this is a b, so that's all I can do. The next example is 5 times 6a minus 2b, and you can do the same method that you did before, distribution, or we can reinforce what we did previously and make an area model. This is the length, this becomes the width, so my area is equal to my length times my width. So if I have a length of 5, and visually I'm going to switch these for what you think, and this is 6a, and this part is a negative 2b, we want to find the area. So the area of this box right here is length times width, 5 times 6a. I multiply the numbers, and we get 30a. And then I want to do the second part. For this box, find the area. So length times width. So 5 times a negative 2b. A negative times a positive is a negative. 5 times 2 is 10, and we stick the b after it. And now we add the parts. 30a plus a negative 10b. And if we have adding a negative, that's the same as subtraction. You will get the exact same answer if you do this method properly as you do if you have distribution, because you can see that the parts are exactly the same. And those are exactly the same. It's up to you to determine which method you prefer, but what we're going to do is get into monomials with variables. So I'll do the first one using distribution, and the second one using the area model. So we want to multiply 5x times everything in the parentheses. 5x times 2x, the negative sign comes down, and 5x times 3. When we're multiplying, we multiply the coefficients in front, and when we're multiplying an x times an x, so x times an x, if I complete that shape, it becomes an x squared. These are each x to the first, and when we're multiplying with the same base, we add the exponents. Over here, we have negative 15x. And we want to double check if we can simplify it any further. While looking at this, they both have coefficients, they both have variable x's. This is an x squared, this is an x to the first. So they are not like terms, and that is my answer. We're going to do an area model for this. So I'm going to use this as my width, and this is my length. Remember, length and width can be changed around. My area comes from multiplying those. So I'm going to take 6y and multiply it by 3 parts because this is a trinomial. It's got 3 terms. The opposite of y squared, a positive 2y, and a positive 5. So we want to find the area of each rectangle. Length times width, so a negative 6y times a negative y squared. Well, if I have 2 negatives being multiplied together, that's a positive. This one has an imaginary 1 in front of it. And this exponent on the y has an imaginary 1. So we've got a negative 1 times a negative 6, which is a positive 6. Add our exponents, so 6y cubed. We have to look at this next one, negative 6y times 2y. Both of those have imaginary 1s on the exponents. And negative 6 times 2 is negative 12. Y to the, since we're multiplying, we add the exponents. And our last one, length and width, negative 6y times 5. So negative 30y. We want to pull each of those numbers out because the total area is what we're looking for. And if we want to find our total area, we want to add all of our parts together, each of the areas of those boxes, and simplify. It looks like we might have a like term, but in fact we do not. They have the same variable, but they have different exponents. 3, then 2, then 1, and that's in standard form. Remember, standard form, as we learned, is in descending order in one variable. So this is our answer. Alright, so let's take a look at these. These are a little bit more challenging because there's 2 distributions on here, and then we're going to have to combine for like terms. So pause the video and try these really quick. Alright, so let's run through how to do these. We're going to do distribution on the first one. So 4 times everything in the parentheses. And then when we're looking at this, we're not distributing 3, we're distributing negative 3. So negative 3 times x squared, that's the first one. And then we have to take a negative 3 times a negative xy. And we need to simplify. We have 4x squared plus 4xy minus 3x squared, and a negative times a negative becomes a positive. And that's where most people make mistakes. So we're going to take a second, go through and look for any like terms. We have a like term here in our x squared, and a like term here in our negative 3x squared. We also have a like term with positive 4xy and positive 3xy. So when we are adding our coefficients, 4 plus a negative 3 is 1, and 4 plus 3 is 7. And since we are adding, we're counting how many we have, and we're not changing our variables, and we're not changing our shape. Alright, let's take a look at this one. To start, you should have started by distributing 7x. So since we are multiplying, this changes our exponents. Exponents become squared here because we're adding the 1 plus the 1. We've got negative 28x plus 2 times 2 is 4, and x times x is x squared. Like the first term, those are exponents of x to the first, minus 8x. We have like terms here. We again have x squareds. And I'm taking the sign in front because that tells me about my number. And I have negative 28 and a negative 8x. So combining our coefficients, 14 and 4, we have a total of 18x squareds. And when we're looking at our x's, we've got a negative 28 and a negative 8, and that's a negative 36x. These are not like terms. One is an x squared and one is an x to the first, so that's my final answer. These are the types of problems you're going to be doing tonight for your homework.